Live streaming is on. Streaming is on.
All right. So, Jamal, you can go ahead and get started. I'm just going to turn on my video and you can start. If you're speaking, Jamal, you might want to unmute yourself.
All right. There's some kind of lag between like the slides, so I know what we're probably the internet connection is slow or something.
Don't worry about it.
All right. All right. So, good everybody. Sorry for the delay. So this talk is about Hasura and the power of GraphQL. So today I will demonstrate like the basics of GraphQL. So the agenda today is basically we will recap on the REST, which will be a quick recap on REST APIs. Then we will look at GraphQL, see what GraphQL is. And then we will look at how you can build a GraphQL API with Hasura. And using, well, before I show you how you can build a GraphQL, I will show you how you can use a GraphQL with Hasura. And then we will look at how you can extend the source out of like custom business logic. And finally, I will show you how you can create an Hasura server. And then we will conclude, and then we'll, I will try to answer as many questions you guys have. All right, so um, yeah. So normally when we make a request to an API, is called the REST API, right? So we make there's many different types of API. There's SOAP, there's GraphQL, and there is also REST. So when we make a RESTful call, there's a few things that we need to know before we can make a request. The first thing we need to know is the HTTP verb. So normally we would specify the verb in Postman, which would be sort of like post, get, patch, and delete. And then each verb will be paired with an endpoint. And based on the verb and the endpoint, the server will execute some action and return some data. Sometimes we might want to provide some payload or query parameters which will modify the action. And then we can get like specific data. All right, so for example, we can make a post request to the slash articles endpoint, which will create an article, or we can make a get request or a put request. But based on the verb that we use, the action is different. So we might call a get request and we get an article. But if we make a put request, we might change the title of the article. So what's different about GraphQL is that, sorry. Yeah, what's different with GraphQL is that rather than multiple endpoints, we have a single endpoint that we call. And one of the main differences with GraphQL is that the data that you specify on the front end is exactly what you get back from the API. So we make the RESTful API call, the GraphQL call. We already know what sort of data that we will get back beforehand. Which this means that we have much more flexibility for front-end developers. So they already know what data they will get back, so they can easily modify the shape of the user interface to match the data. One of the one of the main things about GraphQL is the out of the box type checking, which will enable us to create enterprise ready and production grade graph websites. All right. So this is what the GraphQL API call would look like. We have a single endpoint, which would be like a post request to the /GraphQL endpoint. And this query keyword here is what we call the GraphQL root type. So the root type is necessary whenever we're making a GraphQL request. So each GraphQL request, we need to specify a root type. In this case, is the query root type. There is also mutation and subscription. Whenever we make a query call, this means that we're getting back some data from the GraphQL endpoint. So in this case, we have within this curly brackets, we would specify the fields that we want to be returned. And in this case, we specify that we want the user with an ID of 1. So you can specify arguments whenever you specify these fields as well. And this user type is the user field is matched to the user type. So based on the type of the field, we can also use more curly brackets, which will mean in this case we want an ID of the user. So the only way we can use curly brackets is if the root type is an object type. So if the field type is an object type, sorry. So in this case, ID is not an object type, so we can't use these curly brackets anymore. The ID field would rather be an integer type. So the response would be a JSON response, which would be of user with an ID of 1. If we wanted, we can modify this query to include username or probably the user's full name or something like that. All right, so because the GraphQL API is client driven, we can just match our request to our UI. So in this case, the UI requires a title and a user, the name of the author. So one of the issues with RESTful APIs is that there one of the main things that the GraphQL API solve is the issue with underfetching and overfetching. So whenever we make if this was a RESTful API, we would need to call the post endpoint, which will probably give us back the title, which our UI needs, but it can also give us back like the body, the user, the title ID, and other like irrelevant information to the post. And then sometimes it might give us the author, sometimes it might not. Whenever we get like more data that we need, that's like overfetching. And whenever we get less data than we need, that's underfetching. So with GraphQL, you can specify exactly what you need and get back exactly what you asked for. And it goes well with like relational data. So in this case, each post would have an author. So you can put author underneath the request GraphQL request, and then specify the name, and it will return the author for each post. And what this means is that whenever we make a GraphQL request, it's usually extremely fast because we get less data already sent within the request. So we get exactly what we need, and it comes in as like a shorter time span. All right, so now I will show you how you can make like GraphQL API calls with Hasura. All right, so I prepared the API with Hasura beforehand for demonstration. So let me just explore it quickly. Yeah. So let's say we have like a website that lists the different clubs across Guyana, like reading book clubs. So we have like the ID of the club, the name, the leader ID, which would be like a foreign key. And then we have like the club members, which would also be like another relationship foreign key. And the leader, well, these two fields here is just like a UI generated thing that Hasura does when you deal with like relational data. But these are the main fields, the ID, name, and leader ID. So this leader and these club members come from the relationship that Hasura creates, which in this case, leader would be an object relationship and club members would be an array relationship. Then there's the club member table. The club member takes the ID, which is the auto-generated ID, the profile ID, and the club ID. So each profile ID would match a club ID, which this means that this profile or this user is a part of this club. And then there's the profile table. So we have the ID, username, user ID, whenever it was created at and the date that it was updated at. So let me demonstrate. Whenever we make a GraphQL API call, we first need to specify the root type. So in this case, I will say query. I want to make a query API call. And then let's say I want to list the club members in this table, like all the different clubs across Guyana. I could type club here, but because club is an object type, you need to specify with exactly what fields that you want. So I can ask for the name. And then when this request goes through, I get back a JSON response, which is the ID, the club ID, and the club name. So this is exactly what my UI might need, but sometimes I might need to like list out all the club members. So I could also request the club members. I could ask for their username. So I get back each club, and under each club, I get back the club members. For each club member, I get their profile and their username. So this is how you could make a query request. You could give your query a name, which would help with the GraphQL tooling that is available. So the name would, you could change it to anything you want. Doesn't really affect the query. I can name this clubs query. One of the another thing you can do with GraphQL is you can specify variables. So if I wanted to grab the club, Georgetown Book Club, and I know the ID of Georgetown Book Club, I can specify an ID variable to return exactly just the Georgetown Book Club. So when you create an ID, you specify this $sign symbol, and then you specify the type of the variable. In this case, it would be integer. Actually UUID, sorry. So there's like with GraphQL, which is the tool that we're using to make these requests, it would give you like hints that you're doing it wrong, or you need to like update your query to fix it or so. So I could, well, with GraphQL, you could also check the docs. Say if you want to like see the type of the club, so you know what's on ID. You can what's the type of the ID that you need to request. You could check the documentation, which is right at the side, and these documentations are automatically generated whenever you create a GraphQL API. So you can look for club. And then it shows me the type and the different arguments I can ask for. So each argument can also have a type. So in this case, I will check the clubs to see what's on, what fields I can request. And these are the ID, leader ID, name. And then there's these relationships I can also request from the clubs. So you can see that ID is of type UUID, and this sign here means that the ID cannot be null. The field cannot be null, the field value. All right, so I can specify the I want the clubs where the ID is equal to this ID, which would be the Georgetown Book Club, or I could just replace this with a variable. So this means that I look in the clubs table, then wherever the ID is equal to 1, I just want this. Wherever the ID is equal to this, I just want this club to be returned, and all the requested fields. Right. I don't know why it's not working.
I don't think you're sharing your screen anymore.
Let me fix it. First. What do you see now?
Yeah.
All right. Let me restart this. I don't know why it's not working. All right, so I can request the clubs where the ID is equal to this ID. And I can ask for the name, possibly the ID. Then I just get back the Georgetown Book Club. All right, so this is how you can request data with GraphQL. You just use the query retype, specify the fields that you need. If you want, you can use variables, which I suppose should work. Let me see. All right, sorry, let me fix this. And then when you define this JSON, you can specify key. So this would mean like each ID would be replaced with this string, this UUID, and then look for clubs wherever the ID is equal to the UUID that I specified. This would still give me the Georgetown book club. If I change the ID now, it would probably give me nothing. Let me see. Yeah, it just fails. Alright. Because of the type checking, that's why it failed, because the syntax must be correct, because we specify that we need the IDs of type UUID, but we didn't specify UUID. We only specified some random string. So that's why it didn't work. Alright, aside from queries, we can also make subscriptions. So I could make the same request with all the clubs. I could ask for the ID and the name. And the difference with subscription and queries now is that with subscriptions, the data is returned in real time. So if I go into this database and I decided to add a club, right? I could add a club, and then the data here would be updated. So you could like listen for changes in the database with a subscription. This could probably be useful for like notifications and like a real-time browser-based game or something. All right. So aside from queries and subscription, we can also make a mutation request. So each mutation now would require. This means that we want to update the data in the database, or we probably delete or insert a new club. We just specify the mutation that you want to perform, and then we can specify the arguments, the field arguments. In this case, you want to insert a club with the ID of Linda Book Club or something like that. And in this case, we want to also specify the leader ID. So the leader ID would be of type UUID. So I need to grab a profile ID. And if I want to, I could say I want some data to be returned. I could say returning ID of the club and the name of the created club. So this would insert a club into the database. Then I get the created club here. So I can then use this on my user interface to probably like redirect to the club page or something. All right. So next up, yeah. Um, aside from inserting, you can also do like a deletion, or you can do an update or something. Just give me a second. Yeah. Sorry. All right. So with GraphQL, you can do subscriptions, you can do queries, mutations. If you want to request data, you use a query to update or delete or insert data. We might want to run a mutation, or we can use a subscription for real-time responses. All right, now I will show you how you can or you could create your own, or you can update this API. So let's say you have like a blog now for this website. You can probably have like posts and authors. So in a story, you could define the table name. So in this case, I will say post. I could add a UUID, which will be the primary key. And I can specify the name of the post, which should be of type text. And then you can also specify possibly body, which should also be of type text. If I wanted, I could add like a create that field and update that field. So I could add this table. And then if I check back the GraphQL documentation, I can see that I could now request the post. I could ask for the ID, I could ask for the name, and any other information I might need for the UI. However, each post should probably have like an author. So I could update this table now. So I have like a author ID. And specify that it should be a type UUID. This would be a foreign key, So I could add a foreign key. I could reference the profile table and say that the ID of the profile actually need to add the column first. I could specify that the ID of the author ID should be the profile ID. This would create a foreign key relationship, and whenever this profile is updated or deleted, I could cascade it. All right. What this means now is if I go back to GraphQL, I could request the post, but I cannot request the author, just the author ID. So to be able to request the author, I need to modify this table and add a relationship. I could go back to the post now, look at the relationship, and Hasura automatically suggests that we should create this relationship, this object relationship, which would mean that whenever we query the post, we can also query the author of the post. I want to name this author. So I can go back to GraphQL now. Make a query now, ask for the post and author. Each author would actually be a profile. So I can now ask for the username. If I wanted, I can also ask for the club this user is a part of. And ask for the name of the club the author is a part of. See, there's no like limit in how the relationship is carried out. All right, so let me insert some data. All right, so we go back to GraphQL now. If I request a post, I'll get back the details of the post and the author. So if we want to, we can also check what is going on behind the scenes with this analyze here. With Hasura, you could analyze what's going on behind the scenes. So every query that we make, it just runs this SQL, generates an SQL that that's related to the query that we made. Then you can also look at the cost and so this is like a Postgres feature that you can see how fast the query was executed. So these values are arbitrary. All right, so we can also look at the state of our API by going to Voyager. So Voyager will show us all of the types and queries that we can make and the structure of our tables. So this will be the query root. So everything is like a graph basically. So you could just look at all of the relationships between each table and so forth. All right. All right. So this is how we can create an API with Hasura, and how we can make request states and test our API and so forth. But sometimes you might want to add like custom business logic, right? So one of the first things you can do is you can create an Hasura action. So each action, whenever we create an action, it will create like a field that we can query in our API. So in this case, we could give the query a type, well, type query. This will be the root type. This means that we need to execute a query in order to execute this action. Each action could have arguments, which would be a GraphQL input type, right? So the input is basically we set this here is basically the language of GraphQL, which is SDL or schema definition language, which we need to specify like types and arguments and so forth. So if we create this action, we could go back to our GraphQL API and type action name, and because the input is username and password, we could also ask for the username and password of this action name query. So when we create action, we could call a REST API. So when we call this action, this endpoint would be it, and these input data would be sent to the REST endpoint. And any header that we would like to forward from our front end, we can also do that. This is one way we can extend the GraphQL API that we created. Another way is we could use a remote schema. So we generally you could create another GraphQL API outside of Hasura because Hasura is not the only place you can create GraphQL endpoints or GraphQL servers. So you can add a remote schema. In this case, I could call it Pokemons, and there is this API. All right, so I can specify the remote GraphQL API. These are like GraphQL APIs outside of Hasura. So if I add this on API now, my GraphQL API itself would be somewhat updated. So now if I come to my API, I can now request a list of Pokemons, possibly the first 10 Pokemons, and after their names, their weight, and their weaknesses. What this would do, this would send the request to to the remote GraphQL API and return a response through our GraphQL API. So if you want, you could create an external GraphQL API, possibly with Django or some other technology, and then you can just hook it up to Hasura to centralize every single API that you have. So another way we could add custom business logic is with right now it's like SQL functions and so forth. Like with Postgres, there's a lot of features that we could use. One of the main features like functions. So we can create custom functions to like do all like special actions and so forth. And then this would generate like other GraphQL field stores that we can use. Or if we wanted, we could just write an SQL and it would generate these fields instead of clicking to manually do it. Now lastly, there is events. So event triggers. So with Hasura, you can listen for like events whenever some data is inserted into the database or so forth. So let's say clubs was updated, we added some data, we can listen for an insertion, and then whenever the club was inserted, we can call it possibly a REST endpoint, and then the club data that was inserted will be sent to the REST endpoint, and then we could up that we can possibly if we wanted we could call back this GraphQL API to do something, or we could possibly let's say a club was created and we want to email every profile that the club was created, we could do that in our REST API. So rather than just listening for insertions, we can also listen for updates, deletes. And I don't know what this is. Anyways, yeah, you can also like specify how many times you should retry if the HTTP request fail, or the interval in which you should retry. There's also you can do cron jobs. So these are like actions that would execute like if you want it could be like every day, every minute. So let's say you wanted to call a external endpoint like every 10 minutes, or every midnight. You can just specify the webhook, which would be the REST endpoint, and the name of this cron job. Then you can specify whatever headers that you might want to send to the REST API. All right, so you can also do one-off scheduled events, which would be an event that is scheduled and it just happens like one time. So you could just specify the webhook, the time that you want this event to run. Then you can look at the pending events, the events that weren't executed yet, and the process, those that were executed. And you can basically see everything that happened before. Yeah. All right. Right, let me show you could create a setup an Hasura service. So you basically have this Docker Compose file. So these Docker Compose files are what you would specify the images. In this case, would be a Postgres server and the GraphQL engine. So this here is Hasura. So the Hasura image would be this Hasura slash GraphQL engine. So this data you can grab it from the Hasura website. So you go to Hasura. You check the Hasura documentation. They will have like a link to this endpoint that you can call. To the name they would like you could download this file here, this Docker Compose file. And then you just do Docker Compose up. And then after you do this Docker Compose up, the Hasura server would be running. But the important thing is this env file. So some reason this internet is really slow. It's disconnecting every minute. Are you guys seeing this?
Yeah, I'm seeing your shared screen.
Yeah, change it.
All right, anything I missed, like you didn't see any this screen share for?
Sorry, what?
Like did I say anything and you weren't like viewing the screen at the same time?
Mm-mm.
No, you were good out there.
All right. All right, I was explaining how you could like set up this Hasura server. So you would like have this Docker Compose file, which you would need to like specify the environment file, right? So in this environment file, which is the server.env, you would specify the Hasura secret. So this secret value is the admin secret that you would specify to prevent any other user from accessing the Hasura console, which is the place that you use to like build the API. And then you could look at Hasura GraphQL role, the unauthorized role. This unauthorized role is the role that, like, if you don't have like a J.B token, you can you can still do some sort of stuff on the API, like some request can still go through. So if we generate an API, there's also these things that we can specify, which are the roles. So if we look at permissions, we can set the insert role. We could create a role. We call this unauthorized. So for this table, this profile table, we can specify whether we want to perform any additional checks, right? The additional checks could like look at is like more fine-grained checks. We can check if the user ID that the user is trying to insert is equal to or not equal to some value. So we can also specify the header values, which would come from the JWT token. So typically, each JWT token that we create with Hasura, we will need to add these custom payloads, which is the Hasura user ID. This Hasura user ID is the user ID of the user in some external database. So Hasura cannot handle authentication itself, so you would typically use something like a Laravel API or something, possibly a Django API. You can handle authentication and create an authentication server. So the only thing that you need to do is create like a user table and handle like login and registration. And whenever the user logs in, the payload of the JWT token would be this Hasura user ID. So this user ID, we can check it, see if it's equal to some value. So if it's equal to this value, this check will pass. If it passes, we proceed to these column insert permissions. So you can say that the unauthorized role can insert ID, username, whichever field that we check here. When we uncheck it, the user will not be able to insert this field. And we can also do the same thing for selecting, updating, and deleting. Deleting, you don't need to specify any fields because you're just deleting data. And this is by table level. So this is extremely granular. And so you can create like complex permissions with a sort. All right. So besides this, you have these Hasura migrations. So whenever you update the database, Hasura would generate like some migrations. So these migrations would be SQL files, which would be in this Hasura/migrations directory. So we need to specify which directory relative to the parent directory of this Docker Compose file that we want the migrations to be in. And then we specify the Postgres database, which would be the Docker Postgres database. And then typically when you're in development, you would set the enable console to be true, which would enable access to this console here. If you set it to false, nobody can access this console because it will be disabled. So next up, you just look at the logs that you can get. So Hasura just generates these logs. You can check for like issues and so forth. All right, so that's it for this presentation. But to conclude, I want to say that GraphQL is just like an alternative to REST. You don't need to use GraphQL. It's like just a tool that you might weigh pros and cons. But there are a lot of benefits with GraphQL. Hasura is just like one method you can use to create the GraphQL API. There are like many alternatives, such as you can use a graphene library with Django, which is easy to set up. There's also type GraphQL, which you could use with TypeScript. With Laravel, there is GraphQL Laravel. And there's also like hosted solutions such as 8base and GraphCMS. And yeah, GraphQL isn't perfect. There are some issues with GraphQL, such as the n+1 issue, which is a popular issue in computer science. And there's also these caching issues people have came across with GraphQL. Yeah, it isn't perfect, but it can solve a lot of problems that REST API presents. All right, see, let me know if you got any questions that I should answer, like something I probably didn't cover.
Yeah, great question. Great presentation, Jamel. First question that I have is, what are some of the real-world applications of Hasura and GraphQL? Like, where does it really
So,
shine?
all right, let's say you created it, you want to create like a, one of the main things with GraphQL is that it can handle a lot of load. Well, not really GraphQL, but Hasura. Hasura can handle a lot of load. And anything that you could typically build with a REST API, you can build with Hasura. But Hasura just helps you with creating these basic CRUD functionalities. But if you need like custom business logic, such as like calls, like machine learning, as like attaching a machine learning model or something like that, you need to use these actions, these Hasura actions. But anything you want to build, you can use Hasura. So for typically you would use Hasura for like medium-sized to large-sized applications. But you can also use it for small size because it's good for prototyping, but the front end side of things has a learning curve that you might need to go through, but such as like certain clients like Apollo clients, which you would use to call a GraphQL endpoint, that's a learning curve. But there are alternatives to Apollo client that you can use to get a website or mobile app up and running quickly. But typically anything you can build with a REST API, you can build with Hasura. Especially like complex applications with like a lot of relationships. So you don't really need to grab data from one endpoint and then after this endpoint you call another endpoint based on the previous data. With Hasura, you could, or on GraphQL, you could just grab every single data you need for this interface at the same time. Yeah.
Yeah, well,
Anything.
while the presentation was going on, I kind of did a little more. So Hasura seems to be just the layer that sits on the GraphQL database, and Hasura is specifically for Postgres DBs,
Yeah.
and there are a bunch of different variations. In terms of the major customers, it seems like they have BVBA, which is a huge bank. There's a robotics company. So it seems to be catching a fair bit of traction, both from government agencies and private sector. But so it just seems to be like one of the tools that you can use, but there are many others that you can put on top of a GraphQL.
Yeah.
Like, what's striking with this is that we can set up a data portal rather easily. And, we can have a number of disparate data sources, just aggregate all of that data, and then use the querying feature to really cross-reference and pull exactly what we need. That's what it seems like to me. But how does it do in terms of performance? How good is it with large, like really large data sets?
Well, it can handle like a huge amount of data, and it's like extremely quick based on, well, the Azure website said that they can handle like thousands of requests, and it has been scaled to like millions of requests before, and it can handle like thousands of requests in like seconds or in like a 50 MB RAM server. So yeah, it doesn't, it's not extremely heavy. It can handle a lot of data. And the problem with that, the problem that I mentioned with N+1, with relationships and so forth, Asura has solved that problem, so you don't really need to worry about the N+1 problem anymore.
Yeah, I kind of a few questions. So this seems to give a lot of power to the front end developer in terms of having, just to be able to pull data very easily.
Yeah.
Is there what how do they facilitate authentication? Because I mean, I think the problem that they'll have is when people start to do very very large queries.
Yeah. All right.
So
So typically when you create the regular REST API, right?
mm,
You would all specify like the username and password to log in, right? But
yeah,
Hasura, you can't really do those sort of things with Hasura. You just the only thing you need to pass, right, is the bearer token to Hasura. So it's like you call in not a front end sort of. You just specify the bearer token whenever you call this endpoint, this GraphQL endpoint. And so the bearer token wouldn't come from a storage, except it would come from something like Laravel or so, right? Which is the JWT token. So each bearer token needs to have like this accessory user ID and a namespace, like a URL, setting that saying that every key value under this object in the JWT token should be parsed by Hasura. So Hasura parse this GraphQL, this JWT token to extract the necessary values such as the user ID, and then you can basically check the user ID to handle permissions and so forth.
I see. And can you switch this on? So a source seems to be specific for Postgres, right? Let's say this was switched to like a MySQL database. Is the syntax
Yeah.
that you see here that we're using for Hasura completely different if we switch over to another one of these?
In current starting areas.
So
Yeah.
let's say we look for a GraphQL solution for MongoDB or MySQL or any one of
Yeah.
these databases, right?
Yeah.
This the syntax that you're using for this GraphQL code, is it portable to if I switch the database that I'm using?
No,
Like
you could
so this is
just
specific
well,
to Sura.
yeah, this is specific to Postgres is specific to Hasura, but any database typically you could use it to create a GraphQL API, but you would need some different technology to create the GraphQL API.
Yeah, well
There's
I
also
think in the database, but the GraphQL scripts that you wrote, right?
yeah,
Does
yeah,
that apply across the board?
yeah, yes, across the board.
Oh, okay.
So it's just like the syntax of GraphQL itself. So Hasura just like generates it automatically for us, so we don't need to do it manually.
Yeah, I'm also reading here. Apparently, Shopify just made the transition to supporting GraphQL as well.
Yeah, GraphQL was released in 2015, and since then it's gotten really popular. It has improved like over the years now.
What
Time
I
to
really
review
like is in
QSR
here.
again. Yes.
No,
You
go
heard
ahead.
me? I said time to reveal QSR again.
Relax. Relax. We got a lot to do. But what I really like is the decoupling factor because technically once you design the schema, right, the the backend developer and the front end developer can work at the same time.
Yeah. So with GraphQL, you could just keep updating it. You don't need to like do any versioning and so like people doing like REST APIs.
I'm interested.
So you can
And
easily scale it.
is here. Is here. Probably check that. Yeah, when he showed the subscription feature, my thought process came to that whole 3PL warehousing and the big debate over syncing databases. I would imagine if it isn't too hugely load intensive, right?
Yeah.
Then this would work perfectly for something like that, Ella.
Yeah, I thought so too. First time I saw it.
Yeah.
But I didn't want to upset Asa.
Yeah. I think this it'd be good to try this out and see just how it stands up on something. Like I'm thinking,
we can do that data portal.
Hmm?
We can do a simple data portal to see because I really think it has um, it has a good fit with regards to a data portal concept,
Yeah.
and then being able to have such control over the actual query language, and for efficiency's sake, it makes sense.
Yeah, it certainly saves time in terms of development. Yeah, it saves time. I'm just wondering if there's anything too complex that we do on the QSR backend where it will not work. Gosh. But it says the case that you have these action triggers that you can do once you've consumed the data, right?
Yeah. So if you need to like call a REST endpoint, you could possibly use Hasura to like speed up development and just keep using the graph. Let's say you have a Laravel API, you could just keep using it and keep expanding that. But for like basic front end, so you could stick with Hasura. But custom business logic, like they could just exchange it between Hasura and the Laravel endpoint.
Hmm. So I think it would really depend on is there our majority of our endpoints just data consumption endpoints rather than us actually executing extra business logic. Yeah, because if all you're doing is seemingly consuming data to then do all of that on the front end, then I think this works perfectly. There's some backend stuff that we do with QSR. But yeah, I like it. I like it. I'm gonna take a deeper look at this myself.
Oh, yeah, and if I just say that, for example, with GraphQL Pokemon, right? This external GraphQL endpoint, which is this endpoint, right? You could also do like relationships between, like when we create like a table or so forth in a story, you can also do like relationships between the Pokemons, possibly. Or you could add a remote relationship. You could do
Yeah,
like
yeah, I saw
remote
that.
relationships.
You have distinct schemas and you can just
Yeah,
combine all of those data endpoints in one. So I'm
yeah,
looking here at an article. It seems like the things that is so in terms of what's bad, it seems caching seems to be a problem.
yeah.
Yeah, you can't cache on
But
web and mobiles yet, but you can use libraries like Prisma and Data Loader to help.
yes, well, in terms of server caching, I don't think like it would be much of an issue because Azure is extremely scalable and performant. But in terms of the front end, there's the Apollo library that does like easy cache, like automatic data caching, so you don't need to worry about the state of the application and so forth. So if the like what Apollo would do is like if the data is the same on the server, right? If the data is the same as the server on the front end, it wouldn't like execute any additional requests. But if suddenly the data changes, the Apollo client would update the data. So it only makes calls if it's necessary.
Mhm.
That's in terms of client side caching.
Yeah, and then another one seems to be, and I don't consider this to be a major issue, but I can understand where it comes from. So this article seems to
Yeah,
be speaking about query performance, and this most likely comes down to just developers designing very bad queries. So because you have this given flexibility comes a lot of power in terms of what you could execute. So you can imagine it doing like 25 joins or something, and just pulling huge resources of data. They can then crash the server. And if you need that type of functionality with a REST API, you can perform the optimization with your custom code.
Yeah.
So I can understand it there. But that's really just, write good code, then you don't have the problem.
Yeah, true.
Great power comes great responsibility. Yeah, let me share this. Let me share this article. It seems to be some good information. But yeah, I like to say very good presentation. This is some very useful information. I definitely learned something today because I haven't taken any time to really look at GraphQL at any point, or even knew what Hasura was to begin with. So yeah, and this is very good work, and you have this up in this was pretty concise, and we have this up in a pretty good time. So kudos to you. Yeah. Anybody else have any questions? Comments? It's okay for you guys to talk.
I think we probably asked all the questions. Sorry, guys.
All right.
Yeah. Well, I like anything that's decoupled and resembles a node type structure, so more the relationship. So yeah. I see Sean on the YouTube stream said he definitely learned a lot, so praise there. Good. So I guess if there's no further questions, we can go ahead and more or less wrap up. So again, I just like to thank Gimel for putting this together. It's always good when we can come together and share information like this and learn something new. And I'm definitely excited for us to probably try this on one of our upcoming projects.
Great. Awesome stuff, Jamal.
Yeah.
All right. Later. Come.
All right. I'm going to go ahead and end the live stream here.